Hello everybody, it's Ryan Castro here, and this is a presentation on Archibald V. Hill and his work on maximal oxygen uptake, or better known as the VO2max formula. I am a current kinesiology major, and so physiology is kind of the overarching category that kinesiology falls into, whereas physiology is the scientific study of normal mechanisms and their interactions, which works with the living system. Kinesiology is the study of the movements of that system, or the movement of the body, which the human body is an amazing thing. It's an amazing gift from God. It's able to mend itself by growing new tissue. It's able to cure itself by producing antibodies, and even more exciting, it constructs its own pathways of producing energy, and we'll get to that a little later on in the presentation. But our understanding of the human body continues to grow with the advances in technologies and modern forms of research, and our data in physiology can be better understood when physiology incorporates mathematics via equations and formulas. So, moving on to this next slide, physiology and mathematics. And what I found very interesting was that we share a few terms in common. An example of that is the physiological term homeostasis and the mathematical term system stability. And they have a similar conceptual basis. But what I've found to be most important is once we recognize those terms, it's important that physiologists be aware of the technical similarities as well as the differences between the terms. So mathematical computations have been seen in arithmetic calculations and concepts like blood flow functions, cardiorespiratory output, as well as the forming of ATP. Mathematical formulas and equations can calculate data regarding modalities like speed, weight, distance, and repetition. So we're always trying to find a way to quantify our data. We're always trying to find a way to collect and see progression and see development with the human body. A more detailed look into the VO2max, it's pretty much a way to assess how the body can uptake oxygen, how that oxygen gets delivered to the tissues, and how well our organs and tissues utilize the oxygen during exercise. So what happens is the more that we train our VO2max, or we train our body's ability to receive and absorb oxygen, the more efficient we're going to be. A really good example of this would be swimming. So we find that a lot of individuals who are maybe in high altitude skiing or swimmers have a higher VO2 max because of the fact that their body isn't getting an adequate amount of oxygen, and so it's having to adapt to that physiological change. The key determinant of both elite performance in endurance sports and the mortality in general population can be seen by using the formula of the VO2 max, which you see down below. This is a more detailed formula, and it'll give you a much more exact result. There are a few other formulas that can be used to very quickly get your VO2 max, but it's not as accurate. And if you are in fact training for some type of elite performance or some type of marathon or something like that, I find it, or I would recommend it, to get a more detailed estimate of your VO2 max. So, getting into our VIP, Mr. Archibald Vivian Hill, he was actually the first to define VO2 max back in 1922, and he is considered the architect of the concept of the VO2 max, and incidentally a principal forerunner of sports physiology. Archibald was born in 1886 in Bristol, England, and he attended Cambridge University and did most of his work in the field of muscle contractions, biophysics, and biochemistry, which is where he won his Nobel Prize in physiology in 1922 for his findings in muscle contractions, specifically in mechanical work produced by muscles. So Hill didn't come up with the formula all on his own. There were a few milestones that kind of laid a foundation for him to build upon. The first of which was made by a Flemish chemist and a physician, Jean-Baptiste von Helmont. This was in the 1620s, and he was the first to identify carbon dioxide and was first to coin the term, or use the term, gas to describe the invisible substance. The next big milestone leading up was made by a man named Adolf Fick and he began measuring cardiac output, and that was the big piece that put everything together. Um, from Fick, he created what's called the Fick equation, and that allowed researchers to calculate oxygen consumption relative to body density. So basically, the equation's below, but basically what that means is he was able to figure out lung capacity, or figure out how much oxygen was being inhaled by a person, which was a big finding, and that's where these two correlate. Is that the VO2 max, when you use the proper equipment, it basically is calculating how much oxygen you're intaking and then how much carbon dioxide you're expelling, and then it gets a ratio from that. The next milestone leading up was the discovery of nitrogen equilibrium. So this was a realization on the basis of the constant relationship between atmospheric oxygen and nitrogen. So what that means pretty much is that it calculated the inspired oxygen by multiplying expired nitrogen by a constant, and thereby allowing actual oxygen consumption. So what we're getting now is, instead of just calculating how much oxygen is being inhaled, now we're actually able to calculate how much of that oxygen is actually being used by the body. And below you see the equation that we now still use to find that oxygen consumption. The next milestone leading up, there were two big ones that helped out Archibald, and the first was the discovery that there were multiple metabolic energy systems. There's three actually, and this was a big deal for Archibald, because initially they thought that there was only one pathway to produce energy, and therefore the body at rest on a cellular level would also function the same when the person was being exerted or in physical activity, and that's not the case. There's other functions or other pathways that appear during anaerobic and aerobic exercise. So that was big for Archibald, and that's what kind of paved the way for him to develop the VO2max, or the way that we can calculate oxygen consumption and efficiency during exercise. Now, back in those days, they didn't have treadmills, so the pieces of equipment that they would use to help calculate or to help collect data were too big to be hauled around a circle field during the test. So the invention of the electrocardiogram, it was a small miniaturized device that would fit on the person. It changed everything for Hill. It afforded him the opportunity of monitoring competitive sports performance actually during the time of exertion. Because before that, the data was never precise enough to establish a VO2 max, but because of that device, it gave him the opportunity to collect more data. When we sum it all up, though, physiology incorporates mathematics via equations and formulas like Hill's VO2 max formula. Mathematical formulas and equations calculate data over various modalities, like we spoke of earlier, where it's speed, weight, repetition, so on and so forth. Professionals in the study of physiology, or physiologists, are capable of testing theories and research methods because of the use of mathematics. Archibald Hill, back in the 1900s, was a pioneer of physiology because of his awareness of the technical similarities and the differences between mathematics and physiology. Hill respected and harnessed the power of mathematical computation, and that's what gave him the advantage in these tests and in his development of the formula VO2 max. So that is the conclusion of my presentation. Here's a small works cited page, and I hope you enjoyed, and I hope you learned a little bit about physiology, about the great Archibald Hill, as well as the use of mathematics within physiology. Thank you.